Hi, we're going to talk about abstract base class in this video. So this is the simple inheritance hierarchy that we use to study inheritance. Now, there are three classes here: person, teacher, and student, and it makes sense to instantiate or create instances of each of these classes because, well, there are uh, persons with different first names and last name, and same thing for teachers and students. This is in the inheritance hierarchy that we saw before, and for animals, we keep the information about whether they have backbones and what kind of sounds each animal would make. Now, in this hierarchy, are there any classes that cannot or should not be instantiated? Well, there is, right? Think about, like, for example, just animal or vertebrate or invertebrate. They probably cannot be instantiated because um, they just don't have enough information about them to be usefully instantiated. So, for example, like the animal class itself, remember the kind of information we want to keep is whether the animal has backbone or not, and the sound that the animal is going to make. Now, for the animal class itself, what are we going to assign to the value of whether it has backbone or not? Well, it cannot be true or cannot be false because some animals has backbones and some don't. So the same thing for the sound. It's like, what value can we assign to the sound of an animal? Well, they all different animals make different sounds, right? So it really doesn't make a whole lot of sense to instantiate an actual animal. And same thing goes for vertebrate and invertebrate. So these are kind of the classes that's its purpose is kind of for co-organization and for co-reuse, but it just doesn't make sense to instantiate them. Now, when I presented this previously, one of my students immediately said, well, this really is just saying there's not a single species that we can say is the animal, right? So we can say a dog is an animal, but it's not the animal because cat is also an animal, and so are many other species. So there's no animal per se, but there is dog, there's cat, so on and so forth. Now, having said that, there's nothing in this hierarchy that actually prevents us from instantiate an instance of the animal class or vertebrate or invertebrate. Also, there's nothing here that actually says we have to, when we come to a species dog, that we have to define whether it has a backbone and we have to define what kind of sound it makes. So it would be actually very nice to be able to do both of those things. So that's what the abstract base class is for. Now, abstract base class is not a concept unique to Python. Many other object-oriented programming languages also have abstract base class. So let's use the animal hierarchy to see how the abstract base class or ABC works in Python. So uh, to make a class as an ABC, we basically can use this, well, the standard package ABC, and we import the ABC, which is a class, and we also import the abstract method, but I'll get to that in a bit. And then to make a class, a user-defined class, an abstract-based class, there are multiple ways to do this, but one of the most common way is to just have that user-defined class to inherit from the ABC class. And we can then put the definition for this class in here. For now, it's just going to be empty. Now, I already did that here. Now, so remember though, our purpose is to make it so that the animal class cannot be instantiated, right? Now, just making it an abstract base class does it achieve that? Well, it doesn't, because I can still instantiate an animal, even though it doesn't really have much useful information. So the next thing we have to do is to actually, in a matter of speaking, explain to Python why this should be an abstract base class, that why we should not instantiate an instance of it. Or in other words, what kind of information is missing from this user-defined class. So in case of the animal class, for our very simplified animal inheritance hierarchy, the information that is missing is whether the animal has backbone or not, and what kind of sound that it can make. So to kind of declare that to Python, this is what we do. So we define a method. This method is called has backbone, so it should tell whether the animal has backbone or not. So it should return true or false. But for a very generic animal or the abstract base class, it doesn't know. So we are going to mark this method using a decorator, and that's what we imported up here, an abstract method. We're going to say, hey, this is the information we're missing from animal. And the same thing for sound. That we don't know what sound this animal is going to make, and so we're going to mark this sound method an abstract method. Once we do that, we can run the code again, and we'll see that it's now Python now is telling us that it cannot instantiate the abstract class animal because it has two abstract methods, has backbone and sound. And that's what this slide is trying to say. And right, so one thing I'd like to mention is that, yeah, so for the beta sound and has backbone, we don't have any code in it, so we say pass for now. So this is kind of typical of an abstract method, that it's empty, but it's also possible that an abstract method actually contains useful code, and if that were the case, then usually it means it contains code that some sort of partial implementation, perhaps, that all of the offspring classes can potentially use the partial implementation in the abstract methods. Okay, so moving on, then what about the vertebrate class? The vertebrate class is going to inherit from animal class, and it has the information about the backbones that it actually does. A vertebrate does have backbone, so we can return true here. Now, so in this case, has backbone is no longer a abstract method. Now, can we instantiate a vertebrate? You would expect no, right? We still, because even though we have information about backbones, we still don't have enough information about the sound that a vertebrate makes. So let's see if we can actually instantiate a vertebrate here. And no, we still cannot, because it's still an abstract class, because it's still missing the sound method. But note that it doesn't complain about it has backbone method anymore, because it's no longer marked as an abstract method. So, right, that's what this slide is trying to say. Now, okay, we have a vertebrate class, then we can further go down the hierarchy and now actually define a dog class that inherits from vertebrate class. So dog, we know, is a vertebrate and it has backbones. So and we also now further know that this kind of sound that a dog can make, right? So we can define the sound, or we can overwrite the abstract method that is sound, and we can actually return, have a substantial, concrete implementation, and we can return the sound that the dog make. Can we instantiate a dog now? Well, we should be able to, right? Because at the top, we have two abstract methods. Vertebrate define one of them, and then dog define the other. So let's run this, and now we are good. We can instantiate a dog class, and it has both information about the backbone and the sound of a dog. All right, so that's what this slide says, and now I would like you to give it a try. So, maybe define a class called duck, and duck has a backbone, so it's a vertebrate, and it would make a different sound. So please give that a go. And this will be doing something like this. Just define a sound, duck quacks, and you can instantiate a duck. So as a summary for abstract-based class in Python, in order to mark a user-defined class as a ABC, well, that class can inherit from ABC, and we also have to decorate at least one of the methods with the decorator at abstract method. Now, this decorator can be used to decorate an instance method, but it can also be used to decorate a class method and a static method. So for an abstract static method, for example, that method would have both of these decorators. And so now the abstract-based class itself, or the class that inherits from ABC, obviously it cannot be instantiated, and any offspring class of an ABC that doesn't override all the abstract methods is also itself an ABC. And those classes, as we just saw in the example of vertebrate, they cannot be instantiated either. Now, finally, any offspring class of ABC that overrides all the abstract methods, so it can override the abstract method directly in the class itself or through the inheritance hierarchy through one of the ancestors, then those classes is no longer an ABC and they can be instantiated. So what is the purpose of ABC? We just saw that, yeah, one thing is we make sure ABC cannot be instantiated, but more importantly, the way I see it is the purpose of ABC is to ensure or enforce all the offspring classes should do a certain thing, right? But it doesn't dictate how they should do it, so that's up to the implementation in the offsprings class. Now, this concept is sometimes called interfaces in other languages, such as Java, and it is actually a very, very powerful, very useful concept. And one of the real-world example that I love to use to explain why it's such a nice ABC is, or interface is such a nice concept is there are many cars made by many different manufacturers, right? Most of us, once we get our driver license, we are able to drive most of these cars. Now, at least, if we don't only know how to drive automatic, then we are able to drive most of the automatic cars. Even though, again, many different manufacturers build the same car, build different cars. So why is that? How can we drive most cars? Well, the reason is that most cars share the same interface for driving, right? You all use a driving wheel to steer, to go left and right, and there's a brake for slowing down the car, and there's an accelerator for speeding up. And that's the same regardless of how the car is actually built. And it's even the same if, whether you drive a internal combustion engine car or an electric car, right? Those two cars, they are built very differently, but we're still able to drive them just because they share, again, the same interface for driving them. And we will hopefully see more examples of ABC in the rest of the class. All right, so I'm going to ask you to try to actually complete the animal's inheritance hierarchy by defining a vertebrate class that obviously it inherits from an animal, and vertebrates do not have backbones, so you can define the has backbone methods and try to instantiate in vertebrate. Okay, and then define the cricket and the B classes that inherits from invertebrate and override the sound method, and then try to instantiate the cricket and bees, and hopefully you can do that. I didn't type out the answer here, but hopefully that's straightforward. Now, here is one more exercise for you, and this is an inheritance hierarchy for polygons. So polygons, the main difference between different polygons is the number of sides that each of them have, right? Triangle has 3 sides, pentagon has 5, octagon has 8, and etc., etc. So take a look at this. Define a class for each of these shapes, and figure out which one to make abstract, and what method you want to mark as abstract methods, and yeah, just kind of complete the inheritance hierarchy for polygons. And here is how I would do it. So I'll define the polygon class that inherits from ABC, and the abstract method that it has is sides, because we don't know how many sides the polygon has. And now once we go down one level in the hierarchy, then we know, for example, triangle has 3 sides, so we can overwrite side, triangle dot side method. And quadrilateral, that's 4 sides, pentagon has 5 sides, hexagon has 6, and octagon has 8. So that's all good. Now what about the classes under quadrilateral? Square, rectangle, trapezoid. Well, they can all just inherit from quadrilateral, and they don't really need to define anything because, well, they all have 4 sides. So hopefully that makes sense.